Mechanical property of solid. Remember, here our main concern is solid. And when we talk about solid, you must have seen spring that retract back once you stretch it out. If you stretch out the spring, you leave it, it will come to the original position. It means solid. So in this case, you will have property of elasticity. Marinder, what is elasticity? Marinder, what is elasticity? When body regain its original shape, not only shape, even size, if we remove deforming force. Make sense? So deforming force is changing the shape of the body. Example, if you are stretching the spring out, so the force you are putting by using your hand is the deforming force. This deforming force is responsible for change in the shape of the body. But as soon as you leave it, it will come to original position. Chandana, what are the example that have very good elasticity?
Sir, rubber spring.
Yes, rubber spring, but one of the best is quartz fiber. The example rubber spring we see, but no doubt it regain its position, but not completely. In case of quartz fiber, it is more accurate. I won't say 100% regain, but more accurate. This is one elasticity. Tuhina, what is plasticity?
Sir, it the ability to deform, sir. Like how much it
Ability to
deforms.
deform. Huh. So in this case, it will not regain the original position. It means if you are deforming after certain limit, it will not come to the original shape, whatever you do. Can you give some example, Barinder? How many of you are actually hear me and respond? Barinder, Chandana,
Yes, sir.
Jordan, and Tuhina.
Yes, sir.
So it means only two of you. So Chandana, what is the example of the plastic body?
Sir, wood.
Wood. Yes, wood is one. Putty, wax. If you do it, you change the shape, it will deform and become permanently deformed. Correct?
It's clay also.
Yeah, clay also. So anything like that sort. Even if you say spring, rubber, these will consider as the elastic body only. Remember, I said ki, um, quartz fiber is best, but it does not mean ki spring and rubber do not have elasticity. Okay. So can we say, Tuhina, if elastic property decrease, what will happen to the plastic property?
Increases, sir.
Increase. Correct? If elastic property is really high, then plastic property will be there. So we can say, and vice versa. And um, Chandana, do you consider all rigid body are elastic?
No, sir.
Yes, most of the rigid body are elastic. They regain their original position easily. Rigid body I'm talking about, not soft body like clay, wax, putty, and all. Okay, it is. Why? Because rigid body will try to remain in the same position whatever you do. Got it, Chandana?
Yes, sir.
Jordan and Brinder, as soon as you can hear me and respond, let me know. Next. Tuhina, what is the deforming force?
So the force which opposes the body.
No.
I'm not really sure, sir. I don't know how to explain it.
Chandana, force that cause change in the configuration, volume, area, length, something it change. Example, you exert force on the spring and it is responsible for increasing the length. So deforming force, correct?
So can you
Tuhina.
repeat?
A force that is responsible for deformation, like change in the configuration of the body.
Yes, sir.
Hmm. Then most important topic that we need in this chapter is stress. Chandana, what is stress?
So
No,
force
no, wait.
by area.
Tuhina, wait. Tuhina, what is stress?
Sir, like
Need
pressure,
preparation.
pressure only, sir.
Need preparation.
Yes, sir.
Uh,
So
and
force by area.
force by area, correct. So remember, when you apply deforming force, this deforming force will be encountered by the restoring, because when you uh, pull out the spring, this is deforming force. As soon as you leave the spring, it will come to the original shape. Reason, restoring force exerted by the body. Any doubt? बुआ मेरा भी बनाइए, मेरी भी दो रोटी अलग से बनाइए. So restoring force. Understood, guys? Deforming force will be equal to restoring force if it is perfectly elastic. In this case, if you take stress, sir, we take too much stress every single day. Is it?
Yes.
Restoring force per unit area. This is very basic, but still very important. And the main chapter starts from here, stress only. Remember where you can make mistake, because I am explaining how not to make mistake. It is a restoring force, not deforming. If they want to give easy but still assertion reason in the physics area, you will not face problem. You know, if stress, this S stress is equal to force upon area, but you will be confused in the what you the nomenclature of this force, restoring, right? Next, Tuhina, what is the pressure formula?
Sir,
Hello,
isn't
pressure
it
formula.
force per area also?
Hello, बहुत ज्यादा, बहुत ज्यादा. हाँ, सही बात है. दिन सगुना का चढ़ा आया. मुद्दा की बात बता, मैं क्लास में हूँ. हाँ, क्या खतर. अच्छा, बताने खतर मैं क्लास के बाद तेरा तेरा फोन करूंगा. कोई इमरजेंसी बात हो तो बता. कोई फोन काट दी, कर करूँ मैं, क्लास खत्म होने दे. हैं? के पी से. हाँ, फिर भेज, इसमें पूछना की बात है. तो तेरी बात सही नहीं आ रही, तो मैं तेरा तेरा थोड़ी सी मैं फोन करूंगा क्लास खत्म हो. हम्म. दिन शगुना
Sir, could you just show the notes once, sir?
Oh,
So
you are back.
yes, I had to go for breakfast. My uncle was calling me.
Okay.
Yes, I got a screenshot and write it down.
Okay. So, Sarah, did you take screenshot?
Yes, sir.
If you took screenshot, then so, Tuhina, this is pressure is equal to force by area. Namita, am I audible?
Yes, sir.
Hmm. Guys, be on time. मैं already
Yes,
बहुत लेट
sir.
होता हूँ. I am there to get late.
We know, sir.
Yeah. So you don't get late. So uh, next time be on time because I will try to be on time. The problem is कि I can't tell you be on time because I myself can't do this stuff. Okay, so uh, Sarah and Jordan and Anvita, elasticity. Any body have ability to regain its shape position once you apply the deforming force. Plasticity, whatever you do, it will not regain. Elasticity is exactly opposite to the plasticity. If elasticity less, plasticity more, and all rigid body will have elasticity because they try to remain in the same position. Deforming force is the force that is responsible for the any change, and in case of stress, we use a restoring force. This restoring force amount is exactly same as the deforming force, but direction is opposite. Example, if you take this spring, now if you increase 1, 2, 3, 4, 5. So what you did in this case, you applied deforming force and length increased. So this force is acting outward, deforming force, acting outward, deforming force. Restoring force will regain its original position, so direction of the restoring force will be opposite. Understood?
So just a question, sir.
Yes.
So do we have any bodies which are 100% elastic or 100% plastic? No.
No, no, no ideal situation exists in the nature.
Makes sense, sir.
No ideal situation. It's just impractical. So your stress will be equal to force by area, but remember which force? Restoring force. This can be asked in the right wrong statement or assertion reason. Pressure is also equal to force upon area. Correct. So now we can move forward. If you see unit, Sarah, what will be the unit of pressure? Force is Newton. Area is meter square, so Newton per meter square. Or Pascal is also unit of the pressure. Stress is also same thing. Anvita, what will be the unit of stress? Newton per meter square or Pascal because overall everything is same. Any doubt, Anvita?
No, sir.
Uh, Barinder, are you there?
Yes, sir.
Is pressure scalar quantity or vector quantity?
Scalar.
Scalar. So stress is also scalar quantity because everything look like pressure. Okay. And this stress restoring force will exist up to elastic limit. Elastic limit means limit or range in which restoring force is acting properly or elasticity is working properly. Because once you cross the elastic limit, example, you had one you had 1 meter spring. If you expand this or stretch it out up to 1.2 meter, it will return back to the original position. The moment you do 1.21 meter, then it will not come to the original position. So this 1.2 meter will be the elastic limit. Understood? Understood, guys? Any doubt?
No, sir. No, sir.
Then stress are different type. Depend what are you changing. If you are changing length, then stress will be the longitudinal stress. Stress will be longitudinal stress. In case of longitudinal stress, your length is changing. Length will change. Remember, I am writing length is changing. I'm not saying length will increase or decrease. Tuhina, can you hear me clearly? Tuhina,
But I can see your like the green thing, like the mic moving, but I can't hear anything.
okay. And other people, Anvita, can you hear me clearly?
Yes, sir.
Then Tuhina, you have some issue from your side. Everybody can hear me except Tuhina.
Yes,
I
sir.
can hear you, sir.
Yes, sir.
So Tuhina, only like you can't hear me. Let me text you. Done. So, guys, in longitudinal stress, first category, we are saying कि length will change. So, length can change in two ways. What are these two ways, Sarah? Sarah, what are these two ways? Tensile strength and compressive. Tensile means you are increasing length, and compressive longitudinal stress means you are decreasing length. Any doubt, Sarah?
No, sir.
So mostly we increase length, but even if you compress the spring, it will again come to the original position. But this is by the compression. That's why. Well, but formula will remain same. Your stress is equal to restoring force per unit area. Next, tangential or shearing stress. Jordan, what is tangential or shearing stress? I will not write many notes here. Only like I'll explain more and whatever is required for your exam, but not much writing part. Mostly exist in case of solid, Jordan, where one end is fixed and when you apply some force, then this end will move.
Yes,
Example.
only the body will move a little bit.
No, no, body will not move because body overall is
No, like
fixed.
the body's shape will shift. They gave us an example, sir, like the not the hydraulics. In trucks, they use forgot the metal's name, but then because of that, it's a little bit more stable. The trucks.
See. So example, if you take this, So if you apply force on this end, F force, so what will happen? Your lower end is fixed. Example, this part is fixed. So when you are moving, only upper part is moving, not the lower one. So what will happen? It was supposed to be like this. Okay. But now it will be like this. So you can, it was supposed to be like this. But in reality, it is like this. So what is happening in this situation? Your angle is changing. Overall position is same, but your angle is changing. Tangential stress or shearing stress. Any doubt, guys? Because this lower level is fixed. Understood? I didn't make the whole thing, but that is the ultimate point. Got it? Last stress is hydraulic stress or bulk stress or volumetric stress. So all the name are important because they can ask in the different form. Hydraulic, bulk, modulus of elasticity you must have heard in the waves chapter, right? Bulk modulus of elasticity. Jordan, what was Newton's formula for the sound and Laplace correction? Laplace correction. Jordan, are you there?
Yes, sir. Newton's formula is V is equal to root of E by rho. Oh, sorry, E by P pressure.
Uh,
But then Laplace's correction,
I
he took
will.
he took this. I don't remember, sir. I'm trying to recall.
Sandhana,
No, sir, I don't remember.
Anvita,
So he took the system as adiabatic.
yes. This is Laplace correction and extremely important both the formula, especially Laplace because you can compare with the Newton. This is Laplace correction. Okay, in this Laplace correction, what is happening? Here you have extra Cp by Cv. So this is considered as adiabatic condition. Air is adiabatic. Sound, because you are talking about sound in this case. And according to Newton, air is isothermal because when you are passing sound through air, value is coming 280, but in reality it is 330 because this gamma value is more than 1. Cp by Cv is more than 1. Tuhina, can you hear me?
Yes, sir. Now I can hear you.
What exactly you did to correct this?
Sir, I just switched it off and switched it on.
That's all.
Yes, sir. My phone, it's my mom's phone, sir. It's like 7 years old.
Oh, okay.
Yeah.
So uh, these are the two formula, Newton's formula and Laplace correction, guys. Very important, and why that's the only reason why I am favor in starting full syllabus test now. I mention it multiple time. You will feel, ki, sir, you are repeating. Yes, I am repeating. Reason is, if we do chapter wise, you will never make it like perfect any chapter. Why you won't be able to perfect any chapter? For the neat level, you can do one by one, but by the time you move to the fourth or fifth chapter, you will forget 70 to 80% of the first chapter. You move to the 10th or 11th chapter, you will forget almost 95% of the first, second, and third chapter. Makes sense? That is what happening with you. Got it? So come to the volumetric stress. It says that, example, you have this body, have any volume V. When you apply some pressure on it, then its volume will change. An example, from this, this was the body. Now it became this. So what is happening? Your volume is decreasing after the compression. This is delta V. It is decreasing because of the compression. Okay, volume will change. Volumetric stress. Okay, but remember, it is more for the liquid, because compression of liquid is possible, not for the solid, like permanent compression. For rigid body means what? They do not compress. Any doubt?
Oh, so 1 minute, just copy it.
Hmm. Next part will be too easy. I will finish in this page only. Strain. Change in configuration divided by original configuration. So stress was like, what is the restoring force per unit area? Strain tell us the change, any kind of change. If you are applying force, what it is responsible for, whether it is responsible for change in length, change in volume, change in some angle, correct? And based on this, you have three type of strain. One is longitudinal, as the name suggests, strain in which length will change. So this will be equal to delta L by L. Why? Because length is changing. Longitudinal means related with the length. Done. Second is shearing strain, because we had shearing stress, shearing strain. In this, your angle will change. Remember, angle is changing with responsible to the length. So your main concern is tan theta. It depends what how it is changing with respect to length. Though it look like L only, but difference is here angle is changing. Here angle is changing. Okay. And last, volumetric strain, as the name suggests, where volume will change. Volumetric strain. It means it will be equal to delta V by V, volume. As the name suggests, it is related to volume. Done, guys. Stress strain. That's all. I want to be honest. I think there are 13, 14 questions. We can finish in this class only, all the questions. Are you done with it?
Yes, sir.
If you are, let me come to the one of the very popular formula, and you must have seen the reel on this Hooke's law. Ki if Vishnu, if Ohm's law is given by Ohm, who gave the Hooke's law? And Vishnu is like, oh, Ohm. Ohm is the answer. Did you watch this reel, or it just I felt that
No,
this is
sir,
popular?
I haven't watched it.
No, sir.
Let me check in the mobile if it is.
Maybe your real selection is just bad, sir.
My real selection is bad.
Your feed is just for meant for like what old millennials.
Let me check. Hooke's law. Let me check. Let me show you guys. I got this. Not exactly real, but tell me whether you watch this on Instagram. Hooke's law funny reel. This one. Let me stop.
विष्णु देख, जब मैं कॉलेज में आया था तो मेरा सीनियर था, है कि नहीं? तूने मेरा रैगिंग भी किया था।
हाँ
फिर अपन सेम क्लास में आ गए। उसके बाद मैं तेरा सीनियर बन गया।
हाँ
उसके बाद मैं पास आउट हो गया और मुझे इधर ही नौकरी मिल गया।
कंग्रेचुलेशंस।
थैंक्स। तो अपन इस टाइम है ना मिलके पास हो जाएंगे।
हाँ
कब से है ना इधर?
हाँ
अभी नहीं चाहिए अपने को, ठीक है ना? तो मैं तो सिंपल क्वेश्चन पूछता हूँ, एकदम सिंपल।
हाँ
ओम्स लॉ किसने बनाया?
लॉ ने।
देख देख विष्णु, अगर हुक्स लॉ हुक ने बनाया तो ओम्स लॉ किसने बनाया रहेगा?
हुक ने।
कैसा रे? कैसा?
लॉ ने।
लॉ कैसे बनाएगा? देख, समझ, तू विष्णु है, तू विष्णु है, तू विष्णु है।
विष्णु है।
Did you watch this video before?
No, sir, never.
No, sir.
विष्णु
हाँ.
देख, जब मैं कॉलेज में आया था मिल गया।
कंग्रेचुलेशंस।
थैंक्स। तो अपन इस टाइम है ना मिलके पास हो जाएंगे।
हाँ
कब से है ना इधर?
हाँ
अभी नहीं चाहिए अपने को, ठीक है ना? तो मैं तो सिंपल क्वेश्चन पूछता हूँ, एकदम सिंपल।
हाँ
ओम्स लॉ किसने बनाया?
लॉ ने।
देख देख विष्णु, अगर हुक्स लॉ हुक ने बनाया तो ओम्स लॉ किसने बनाया रहेगा?
हुक ने।
कैसा रे? कैसा?
लॉ ने।
लॉ कैसे बनाएगा? देख, समझ, तू विष्णु है, तू तू विष्णु है, तू विष्णु है,
मैं विष्णु
हाँ,
है,
तू विष्णु है,
विष्णु है।
वेरी गुड, अरे मालूम है तेरे को, चलेगा। तू विष्णु है, तूने चपाती बनाया, तो ये चपाती किसने बनाया?
विष्णु ने।
वेरी गुड, समझा? किसने बनाया? तो उसने बनाया, समझा ना? हाँ, तो तू ओम से, तो तूने एक लॉ बनाया, तो लॉ किसने बनाया? ये तूने बनाया, ये लॉ तूने बनाया।
हाँ।
तू ओम है, तो ये किसने बनाया?
ये चपाती है।
ये चपाती नहीं है, अभी चपाती हो गया, चपाती एक्सप्लेन करने के लिए था। तू ओम है, तूने ये एक लॉ बनाया, तो ये किसने बनाया?
विष्णु ने। विष्णु ने। श्योर।
मैं कोशिश कर रहा है। अपन को क्या होने का है? क्या होने का है? क्या बोला मैं पहले? अपने को क्या होने का है?
वाइवा।
वाइवा तेरी कब वाइवा कब पास होने का ना अपने को? होने क्या नहीं होने का तेरे को? होने का ना? तो तू अभी ओम है। अबे छोड़ यार, छोड़।
मैं ओम है।
मुझको ही मारता हूँ।
मैं ओम है, मैं ओम है।
अभी गाना सुनता है?
हाँ।
गाना सुनता है?
हाँ, हाँ।
शांति क्या है? शांति हिल क्या रहा है बुद्धू? क्या है?
शांति।
शांति कौन है? कौन है शांति? कोई मिल गया देखा है? देखा है ना? तू तो 20 बार देखा रहेगा साले। वो क्या है? ओम 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 ओम
ओम ओम।
पास हो गया, पास हो गया।
ऋतिक लॉ, ऋतिक लॉ, सर लाइक सिंटैक्स लॉ, जादू लॉ,
पास हो गया ये।
जादू लॉ,
Yes.
सर क्रिस
पास
लॉ,
हो गया।
क्रिस लॉ सर।
यस, भाग यहां से, भाग बुद्धू, निकल।
Guys, did you watch this in real?
No, sir, but it's been
No,
long
sir.
since I've seen Scoop Poop.
Aho Karang, hello. So this was the video, and I think I have watched this many years back, probably 5, 7 years back. It's just because it was having topic Hooke's law and Ohm's law, so I just recalled it. Come to the topic. So, Chandana, what is Hooke's law? Who made Hooke's law?
Food.
Okay, Hooke. Great answer. What is Hooke's law?
So stress is directly proportional to strain.
Stress is directly proportional to the strain. It means if you are changing length too much strain, if you are increasing delta L, it means longitudinal strain you have a lot. Then there will be more stress. Why? Stress means we are talking about restoring force here because area will be same. Our main point is restoring force. If you increase length, then restoring force will be more. Correct? Stress is directly proportional to the strain. Okay, strain means increase in length. Let's take only length part. Increase in length. Stress, restoring force. More restoring force will act if you increase length. Understood, guys?
So can you repeat that again, sir?
If you increase length, you take longitudinal strain, for example. So if you increase more length, then restoring force will be more.
Yes, sir.
Can we say, like, I'm just taking for the example here, this restoring force will depend upon the delta L. More length you increase, change you do, then there will be more restoring force. Make sense? Any doubt, guys? So stress is directly proportional to the strain. In this case, you can say extension, change in length directly depend upon the load, more force. If you apply external force, load means external force. Load means external force. Extension means change in length. Extension is change in length. And when you remove proportionality constant, it will be E. proportionality constant, it will be E. So stress will be equal to E into strain. So if you want to calculate E value, it will be stress upon strain. It will be stress upon strain. Barinder, what is this E? Modulus of elasticity. Modulus of elasticity. Any doubt, guys? Anybody?
No, sir.
If you don't have stress, this modulus of elasticity can be different type, depend upon which type of stress and strain you have. Bulk modulus of elasticity, correct? Young modulus of elasticity. So all these formula will remain same, stress upon strain. Doesn't matter what stress or strain you are considering, overall things will remain same. This is Hooke's law and explain modulus of elasticity. Using this, you can also explain stress strain curve. This curve is also important, can be asked in your exam. How many of you are there, by the way? 7. Barinder, Anvita, Chandana, Jordan, Sara, and Tuhina. Okay. So, if you take stress strain curve and you make graph, here you take stress and here you take strain. Strain means always consider increase in length. It will be easy to compare. You can take anything, you can take volume also, you can take angle also, but increase in length is easy to achieve. You are stretching out the spring. So, Anvita, what is the main factor in the stress that we are considering here? Anvita, what is the main factor in the stress that we are considering here? Restoring force? Yes or no? Anvita,
Yes, sir.
like in stress, we are considering restoring force because stress
Yeah.
formula is restoring force per unit area. Area is fixed. So
Hmm.
only restoring force will change. What do you mean by restoring force?
So the force like required to bring back to the original position or whatever, like size.
So we are applying externally this restoring force.
No.
Then
So we apply the normal force. Suppose we change the length, we stretch
hmm,
something, but then when we leave it, the like restoring force, like it, how do I say? Like we don't do anything for the restoring force. It's like on its own. Like
hmm.
I don't know how to explain. So
No, this is the correct explanation. Restoring force is exerted by body itself. We are not applying it. We are applying deforming force. In response to deforming force, to bring the body back to the original position, body itself, particle, atoms, or molecule are exerting restoring force. Okay. Why I am telling this, you will understand when you see this. Here you are considering length, like change in length. If you increase the length up to certain limit, it will come back to the original position. Up to A, you can easily feel the Hooke's law. Up to A, you can see like directly proportional. If you increase length, restoring force will increase and it will try to bring the body back to the original position. Any doubt, guys? Even if you slightly increase the length up to B also, body will come to the original position. Okay. Up to B, Hooke's law is followed. After that, you can see कि you when you go to from B to C, here this curve become flat almost flat, not exactly, but almost flat. What does it mean? When you are increasing strain, restoring force is not sufficient to bring back the body. And after that, whatever you do, it will be responsible for the plasticity. And if you increase too much, then spring will break. It's like you are sorry. वाह मैं तो तुमसे एक लेते पहला बड़ा ले 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 मैं और मैं खाऊंगा मेरी माँ को नहीं खाती तेरी माँ का न्याला दे दिया एक काम बढ़िया का रखा है मुझसे एक काम बढ़िया का रखा है मीठा कम है इसमें यह बढ़िया काम का रखा है अभी सही पड़ रहा सूखा तो नहीं ना सूखा को नहीं घी तो मैंने ध्यान को दिया लेकिन मीठा कम है यह अपना बढ़िया लग गया एनी डाउट गाइस
No, sir.
So up to B, if you apply external force, body will spring will come to the original position. Okay. After this, if you increase the force, external force, strain is like external force. It's like external force because only due to this external force you can increase the length. Okay. Only because of this external force you can increase the length. So it will become flat, like a spring will become flat, it will not come to the original position. Even after that, if you keep on increasing the length, increase, there will be limit you cannot increase and it will break. And that's the thing. Board people in like simple state exam, they so D is the fracture point. If you try to increase length, because there is a limit up to which a spring can extend, then it will break. Any doubt, guys?
No, sir.
So I will write here only. Note it down. All these names are really important. What is the meaning of each line?
लेती दूरा कुकर नहीं दो देगी थी
Ask me, guys. Any doubt?
No, sir.
Hmm.
So one minute, I'll just copy it.
Every point is extremely important. or sometime you will see the same graph is slightly shifted, but restoring force will be there. It will try to bring to the original position.
So just a question.
Yeah.
So are there any materials which have where the fracture point is the where sorry where there is no plastic behavior?
No, there will be plastic behavior. It just percentage can vary. Example, if you in very good high elastic material like quartz fiber, plastic behavior is less. In case of wall putty, clay, wax, and all these, plastic behavior will be more.
Because
Right?
I was just thinking, if you take glass, for example, sir, everything will be close to each other.
Hmm.
So I was wondering if C and D can be on top of each other, like the same point.
Yeah, it can be. Distance can vary. I will show you. That's why we are using this graph.
Yes, sir.
And it can be this also, guys. I still remember in my 11th class, I did this. It can be this also. Some of the strain can be left out. It can be both. But main point is up to B, you can follow Hooke's law, stress strain exactly correlated. Next, based on this graph, you have three type of material. Material type based on the graph. First material is ductile. Varinder, what happened in ductile material? Large plastic range. It means plasticity is very, very high. And your fracture point will be far because it's difficult to break. Correct? And you can easily convert this kind of material into the thin wire. Easily converted in thin wire. Example, you have copper, gold, iron, aluminium. You can convert this material into the thin wire. Why? Because it's difficult to break them. Like fracture point is very, very far. So if you draw the graph in this case, same graph, stress strain graph. So I will write this is S stress and this is strain. So example, if this is normal A, B, C, and then D will be very, very far like this. So this is D. Same. Meaning of every letter is same, like elastic range, proportional limit, plastic range, and fracture point. But it's difficult to break them because this plasticity range is still very, very high. And when plasticity is high, it means you can convert into the thin wire because they can still expand more. See, in chemistry, we explain the ductile material and malleable, but here we are explaining based on their increase in the length. Opposite to this, you have brittle material. So, Hina, what is brittle material?
Sir, material that breaks easily.
So, if break easily, what will be their plastic range?
It'll be high, sir.
It will be low. They can easily break, na?
Oh, yes, sir.
So, plastic range will be very, very less. Example, glass. Either they remain in the elastic range, or if you slightly increase, they will break easily. Correct? In this case, if you draw the same stress strain graph, then you know the limit will be very less. Example, up to here you have A and very close you have D. Any doubt, guys? Sarah, what will be malleable material?
Some material that can be converted into thin sheets.
Yes, converted into thin sheet. If you are converting into thin sheet, example, Sarah, gold, AU, very good thin sheet material. That's why used in the Rutherford model, because you can convert into very thin sheet. Yes or no, guys? Sandana, how should I draw this graph for malleable material? Is this correct? Like if I draw like this, here you have A point, then B point, and then C point, then D point, something like that. No.
No, sir.
Why? We can't. Why?
Mm. So plasticity is less. More.
We are compressing. We are compressing it. And here example, if you take applied force, when you apply force, process will be same. Up to A, you will have your proportional limit, and after that, it will be like something like B. But it is ulta. Why? Negative, because compression. In other cases, we were having extension kind of air compression. Any doubt? This is really important because in malleable you will see special graph. Last, elastomer. Jordan, what is elastomer?
So bodies which can stretch easily. Like for
Hmm.
example, rubber, they have
Yes.
large plasticity.
Yes. Large range of strain. You can expand too much. Example, if you take rubber, if you take any elastic tissue of iota, so it can extend easily. Iota. So these elastomers obey, do not follow Hooke's law. And in this case, if you draw graph, this and this example, this is strain, this is stress, and it's like this. There is no logic of relation with the Hooke's law. Last one, two important topic, extremely important topic. Extremely means very extremely important topic is the modulus of elasticity, because majority of question you get only from the modulus of elasticity. Whatever we did so far is like you're gonna apply in the modulus of elasticity, whether it is stress or strain, you're gonna apply in modulus of elasticity. That's why whatever we were reading so far will be applied here. And topic name is modulus of elasticity. Anvita, so what is this modulus of elasticity?
So I don't remember the exact thing.
So this is stress by strain. Stress by strain. So if you see this E, it depends upon the nature of material. Because when you are applying force, deforming force, it will be responsible for change in length, and then the restoring force will act. Okay. and it depend upon the nature of material. Example, if you try to spread gold, copper, and silver, then all will uh, work in a different way. Correct? It does not depend upon the dimension, length, area, volume does not depend upon all this, independent of its dimension, independent of the dimension. And what will be the dimension, Barinder, of this E? What will be the dimension of E?
ML minus 1 T minus 2.
ml minus 1 t minus 2. ml minus 1 t minus 2. Yes. Because, see, if you see unit, strain do not have unit. I will write no unit because length by length, no unit. Important. Volume by volume, no unit. Length by length, again, no unit. So strain do not have any unit. When you see this, it will be the same as unit of stress. Unit will be equal to the stress unit, and stress unit is equal to the pressure unit, force upon area. So it will be Newton per meter square or Pascal. And if you see dimension here, force is mlt minus 2 and area is L square. So it is ml minus 1 t minus 2. Yes, Prince, you were right. Any doubt, guys? Based on this, we can solve most popular question asked from this topic is the Young modulus of elasticity. Young modulus of elasticity is represented with the y, and this y will be equal to longitudinal stress divided by longitudinal strain. Longitudinal strain. And I think from many days your notes are not proper. You are sending, but it's not proper. So today I'll check everybody's notes during the class only. What is stress? Force upon area. What is strain? Delta L by L. Many a time, radius will given to you. Whenever you consider area of wire, it will be equal to pi r square. It will be equal to pi r square. And whenever you will see ki there is a same material means your young modulus of elasticity will be same. In question, you will not have explicitly ki young modulus is same. No, they will mention ki same wire have different area and different length. Then your overall y value will remain same because it is the property of material, not the property of dimension. Understood, guys? This is the most commonly asked question from the full chapter, young modulus. Almost 80% question only from the young modulus. Second, bulk modulus. You do get question from the bulk modulus of elasticity also. And in your chapter of waves, you have bulk modulus as well. In this bulk modulus, you have same stress upon volumetric strain. Stress upon volumetric strain. So stress will be equal to force upon area. Volumetric strain will be change in volume by original volume. Change in volume by original volume. Volumetric strain. So this is also equal to the pressure. Pressure P is equal to force upon area as well. So when you write this same bulk modulus, force upon area will be equal to P divided by change in volume by volume, and there you will have minus sign. Who will tell me? Chandana, why do we have minus sign here? Very important. Why? Mostly you see this was liquid because a liquid can compress easily. Chandana, why you have negative sign here?
No, sir, I'm not.
Tuhina,
I don't know, sir.
Sarah,
Not sure, sir.
Jordan,
No idea, sir.
Because it's like opposite or something.
because of
It's opposite.
your voice is breaking, Sarah. Because of
Sir, I think she's trying to say it's opposing something.
Is
opposite
it
something.
opposite, sir?
Opposite
Opposite.
to what?
Uh,
Opposite to what? It is opposite, but what opposite to what? You are right in this. Anvita, Anvita,
Yes.
why negative?
Not sure.
Barinder, answer is example. If you increase volume, delta V you increase, then you know pressure will decrease. If delta volume is positive, then pressure will be negative. Yes or no? Any doubt? If you increase pressure, if it is positive, you are increasing pressure, then delta V will be negative. Overall, whatever, if one of the value is negative, overall it will be negative. Make sense? Many a time you will have, like we'll discuss in the other chapter also, pressure is equal to force upon area. Force is equal to mg by area, correct? And mass will be equal to volume into density, g upon area. Volume is equal to area into length or height upon area. Area cancel. Can you say pressure is equal to force upon area? And you already know this formula, H rho g. But I just proved in the simplest way. Force is equal to mg, mass, density into volume, and you calculate. Any doubt, guys? Because in numerical, you sometimes need this as well. Okay. Next is compressibility in the same topic. Very important because I have seen, I think, 2 questions on this. Total question is, I guess, 14 only. Compressibility. Okay. Extremely important because you might forget this. Because other things are easy, you will never forget. This compressibility K is exactly opposite to the bulk modulus of elasticity. Okay. So it will be pressure divided by change in volume by original volume. Any doubt?
No.
Third is shear modulus. Shear modulus
Sir, why
and
is
this
right negative, sir?
mm, Chandana, because if you increase volume, delta V is positive, then pressure is negative. So your um, numerator is negative and denominator is positive. So overall it is negative. Make sense?
Yes, sir.
If you do ulta, you increase pressure, then pressure is positive, volume will become negative. Your numerator is positive, denominator is negative. Overall, it will still remain negative. Make sense?
Yes, sir.
Huh. Shear modulus is almost like your this Young modulus. Why? It will be same like force acting upon per unit area, change in length by original length. It's just key in the shearing modulus, you focus more on the angle. Your tan theta become equal to delta L by L because we are bothered about the change in angle. And all the three are done. Any doubt?
No, sir.
We are almost on the verge to finish this chapter because this chapter will take next few minutes to finish the whole thing. Next, remaining thing asks very less, but still we never know. That's why we have to cover what is given in the syllabus. Jordan, send syllabus copy once again.
So do you
Then I
want the
will
whole
finish.
PDF, sir?
Yes, this PDF.
1 minute.
Or you can send only this chapter also. Please.
1 minute, so I'll send it to you.
Hmm. Poison ratio. Poison ratio include the lateral strain. Example, you have a wire. This wire have particular width. Let's take this wire have d width. If you
I've
try
sent it,
to,
sir.
okay, if you try to expand this, then there will be increase in the width. Remember, not length, width. That's why lateral strain means we are talking about width. So lateral strain, lateral means width. If you increase the width, what will be value? Change in width divided by original width. Correct? Change in width by original width. So in this case, if you calculate Poisson ratio, it will be the lateral strain we just did above compared to longitudinal strain. In one of the, I think 2024 or 25, 24, I guess, they asked this question. Ki, what is the unit of Poisson ratio? What will be the unit, Jordan, of this Poisson ratio?
Meter. I think there won't be any unit now
No
because
unit. Strain itself do not have unit.
train itself
Strain
doesn't
by
have this
strain
now.
again no unit. So it will be unitless as well as dimensionless. Okay. Usually you will see if I write in the form of formula, your Poisson ratio is change in diameter by original diameter width by change in length by original length. And usually this value of the strain is less than zero point 0.5 overall number because it's just a number which tell you what is the tendency of the material to expand. Okay. Any doubt, guys?
Second is scroll.
Yes. Factors affecting elasticity of material.
Done, sir.
1 minute, sir. 1 minute, sir.
Sure, sure.
Sir, can you explain the lesser than 0.5 part?
It is just number that explain you what is the tendency of the material to be wider,
So this
to
is like
increase the width.
it's always supposed to be lesser than 0.5, no?
Yes.
Okay, sir.
So this number is very, very less. So you can't imagine that there will be too much increase in the width. It is very, very less. That's what we are trying to convey. Correct. Next is what are the factors that affect the elasticity of material? If you do hammering, you hit with the hammer any material, or you do rolling of the material, what will happen in this situation? Material will become hard, rigid, and rigid material have more elasticity. It will increase elasticity. Any doubt, guys? Second is annealing. Annealing means heating and cooling is the annealing. If you do heating and cooling, then it will lose the nature of the elasticity. If you keep on heating and uh, cooling it, then what will happen? It will lose the nature of elasticity. That's why elasticity will decrease. Third, if you heat, if you increase the temperature, as I mentioned, if you beat it, it will become hard. Hard material have more elasticity. And if you increase temperature, then elasticity will decrease. If you heat the material, it will lose, then elasticity will decrease. Got it? And impurity can also impact the elasticity. It can increase or decrease depend upon the nature of impurity. Barinder, can you hear me?
Yes, sir.
Hmm. So in next 5 minutes, I guess we can finish this chapter easily.
So when
Uh,
will the class end?
Class will take approximately half an hour because 14 questions are there. We'll finish all of the questions.
Okay, sir.
Then elastic after effect. Do you know what is this elastic after effect?
Sir, I'm not sure.
Sarah, what is elastic after effect?
I don't know, sir.
Even if you remove your deforming force, instantly it should come, but if take hours to regain the position, it is known as elastic after effect. The elasticity will be shown after you remove your effect for long time. Example, in case of glass, you can see this glass will regain its position. It will take hours together. Take hours to regain original position. So that is elastic after effect. Jordan, what is elastic fatigue?
So after repeated stretching and compression, it it basically loses its plasticity.
Correct. So what happened? Ki, example, if you take spring for very first time, it will easily come to the original position. But if you keep doing every day, 50 times, then it will lose its elasticity. It will lose its strength also. Right? It lose its elasticity, lose its strength also. Got it? Last topic: energy stored in deformed body. Uh, Last topic is energy stored in a deformed body. It means when you are deforming the body, when you are applying external force, then which energy will be there, Anvita? Kinetic energy or potential energy?
Repeat your question.
If you deform the body, if you increase the length, then body will store some energy due to change in the position, because when you apply some force, you
Kinetic
apply some
energy.
energy. It will be the potential energy, correct? Because of its configuration. Kinetic energy because of the motion, and potential
Yes,
energy
yes,
because of its
you're right.
configuration. You
Yeah.
are changing configuration. Right? In this case, if you calculate what is the average force, what is the average force? So it will be zero or maximum. What will be the average of these two? F by 2. Minimum value of force is zero when you remove the force. When you apply, it will be F. What is the average? Taking consideration both the force. Here, when you deform, example, this was the original length of any road. When you deform it, it will stretch out this. What is happening? You are increasing length. And whenever there is energy because of the configuration change in the position, it will be the potential energy. It will be the potential energy. So your potential energy is equal to how much work you are doing. Example, you applied X amount of force on this, and because of this force, there is an increase in delta L. You can calculate work done. Force into displacement. Correct? It will be equal to work done. And what will be the work done value? Force into displacement. Your force F average will be F by 2. ds is actually equal to delta L, because here we are considering you are increasing length. Any doubt, guys, as of now? Any doubt, guys?
No, sir.
Anybody? If you don't have any doubts, this is F by 2. This is delta L. What you can do, you multiply and divide with area and length. Area and length. Barinder, what will be this force by area? Stress.
Yes, sir.
Tuhina, what will be delta L by L?
Right.
It will be strain.
Oh, yeah. Yeah. Yes, sir.
And this, Sarah, what is this area into length?
Volume.
Volume. Volume. So if you take this, it will be 1 by 2. F by A is stress. Delta L by L is strain. And area into length is volume. Okay. This is your energy, potential energy stored when you are expanding it. If you calculate what is the energy per unit, if you calculate energy density, if you calculate energy density, you know it will be equal to energy per unit volume, volume V. So it will be equal to 1 by 2 stress into strain. Do you want, guys, some thrill, adventure?
What do you mean, sir?
What I mean when I talk about thrill and adventure, it is like something extraordinary topic in the same energy density. You can correlate with this with thermal property of matter, which say that delta L directly proportional to the original length. If you heat it, it will also depend upon the change in temperature. So delta L will be equal to alpha, some constant of the material, L length, and delta T. So delta L by delta T is this also. Example. Your original length of a rod is L. You heat this wire and your new length is L dash. What will be the change in length? Delta L. I will give you example for this. Example, you have a 10-meter long wire. When you heat this at 200 degrees Celsius, this wire will become 10.1 meter. Jordan, tell me what are the factors that will decide this increase in the length, delta L?
The material,
Material, material is
temperature also,
alpha,
temperature also
temperature,
can. The
and
amount of force,
original length, because you are not applying any force, you are increasing the volume.
increases volume, temperature, length,
Sorry, length.
the
So
material, what else? I don't know, sir. Apart from
this
that,
is
I think.
these are the only three factors: length, more chances of expansion,
Yes, sir.
nature of material, and increasing temperature. Because delta T is the main responsible factor in this case. Understood, guys? Everybody. So thrill is delta T. Sorry, delta L by L is also equal to strain, which is equal to alpha delta T change in temperature. So same energy density can be written in this form: energy density, which is equal to U by V, is equal to 1 by 2 stress upon strain, also equal to 1 by 2 stress. Instead of strain, can you write alpha delta T? Isn't it this thrill? Isn't this thrill? This, instead of this strain, you are writing in different form. Because why I'm saying it is thrill? NEET asked question in 2024 exactly from the same thing. Because maybe some teacher do teach. I would say 50-50, not ki many teacher don't teach. I guess majority of teacher teach. The thing is, but some do not tell ki this strain is also equal to this, and considering your thermal property of matter in the same topic. Understood, guys? Any doubt?
No, sir.
Yes. So we are done with the mechanical property of solid. Whole chapter. So In this case, I will do a quick revision in just 2 minutes, and after that, you will take 10-minute break, and then we'll start question. 14 question only. We'll finish all the question. First, go through it and ask me your question. I will give time now. Go through the full chapter and ask me your question.
So can you send the PDF right now?
Yes.
Sir, I missed some parts.
Yes, Tuhina?
So some parts I missed, sir. Can you send the notes?
Yes. 10 rupees for PDF sending.
Sir, I am only pauper, sir. I don't have any money.
I am very expensive.
Sir, I don't have money, sir. You're taking money from the poor. You should give charity, sir. You should pay me, sir. I don't have money.
I don't believe in charity.
Oh, sir, this session is recorded, sir. You'll get cancelled on Twitter.
Yeah.
Tanvi's mom will cancel you, that is for sure.
Yes,
What?
my mom's very popular on Twitter, sir.
Her mom's very, very popular on Twitter.
Is it?
Very.
Yes, sir. Something not you'll be
Oh,
tweeting, sir.
I have to be very scared.
Yes, sir, you should be.
So her mom found a video of me fighting online on the internet before my
Jordan,
parents
can
could.
we not talk about your horrible fight with Kenneth?
Seriously. Jordan was famous on Twitter.
Sir, not on Twitter, on
On
Instagram. His
Instagram.
video went viral throughout Bangalore.
Is it? And
Sir,
what
you
was the
don't know
special?
this, sir?
No.
Oh, he fought with some guy in one BMTC bus, sir. And that fight was
Uh-huh.
so bad also. None of them won. Both of them were crying at the end, I think. And
I won.
still,
I banged his head into a pole, Tanvi.
Okay, it's okay, it's okay. So ultimately, what is the
see,
conclusion?
Jordan won the fight. That's all.
Uh-huh.
It was a horrible fight.
Okay. Is it still viral or like it's
No,
long
sir,
time?
died on. This was during
When he
10th
was in
grade.
10th, this happened, sir.
Oh, okay. So finish this in 10 minutes and I will do revision, quick revision in just 2 minutes. A full chapter in two
So
minutes.
what are we supposed to do in 10 minutes?
Quickly read through it. See if you understood everything, you have any doubt. Don't write anything in this time. It's okay
Okay,
if you
sir.
miss anything. Just make sure you understood everything.